Alrighty, and there we go. We have two things left to learn with logarithms. We will learn to condense and expand today. These are important skills because in order to solve logarithm equations, which is what we do next, you have to be able to use all the properties we've learned up to this point, but most importantly, you have to be able to pull logs apart and push them back together, which is exactly what condensing and expanding means. There are only three properties you have to know. The product property, the quotient property, and the power property. The only three properties. They're really simple. This is a lot of mumbo jumbo, but it is super simple. The product property, the word product means to, you know what product means? This means to multiply. This is literally called the multiplication property. The reason it's called that is because it is used when the inside of your logarithm has two or more things being multiplied. If we look at this example, log base 5 of 20x, there are two things being multiplied. 20 times x. See how they're being multiplied on the inside? 20x isn't one thing. That literally means 20 multiplied by x. Those make 20x. When there are two things being multiplied inside of a logarithm, you are allowed to rewrite it. You are allowed to rewrite this as two separate logs being added together. So the log base 5 of the first term, log base 5 of 20, notice, see my base of my log didn't change, plus log base 5 of x. That is called expanding. We rewrote log base 5 of 20x, again, 20 times x, that's multiplication, as two separate logs being added together. Now, it's important to understand these properties go both ways. You can expand them. If you saw something like this, you could also push them together, and that is called condensing. So it can go both ways. Okay, the second property, just like this one, except it's called the quotient. Quotient is a fancy math term for dividing. The quotient property can be used whenever two things are being divided on the inside of a log. In this example, we have log base 8 of 3 over 4. On the inside, we are dividing 3 divided by 4. Since on the inside of that log, we have two things being divided, we can rewrite them as two logs not being added, but being subtracted. So almost the same as the multiplying property. The only difference is we write two logs being subtracted. And the base of this log will not change. We're going to have 2 log 8s. Nothing happens to the base, just the numbers inside. So this will become log base 8 of the top number, always the top number first, minus log base 8 of the bottom number. When two things inside of a logarithm are being divided, we can rewrite them as two separate logs being subtracted. And just like before, this goes both ways. If I give you a single log and ask you to expand it, you would write this as two separate logs pulled apart. If I gave you this left side we just wrote down and asked you to condense it, you could be like, oh, I have a log minus a log. I'm going to rewrite it as one log and divide my numbers. And there's only one more property you have to know. And that property is called the power property. The power property applies whenever we have an exponent. Whenever we have an exponent. If the inside of your logarithm has an exponent, for example, here we have an x to the third power, that's an exponent. We can take that exponent, bring it down and out front of the logarithm. So we're taking it out of the logarithm and putting it out in front. This would become 3 times log 2, and that x is left behind. Just like the other two, it goes both ways. If you ever saw a number out front touching your log, you can always put it back inside as an exponent. These properties all go both forwards and backwards. We just expanded them because we made our expressions longer. You also need to be able to condense them and do what we did backwards. Both are super important and you have to be able to do them in order to solve logarithms. So we're going to practice the properties so that next topic, when we solve logarithms, we can do it using expanding and condensing. So we're going to start off with 4. We might say 4. 4 is a little extra. But we're definitely doing 1, 2, and 3. Expanding and condensing. So starting with expanding. Number 1 is the ln, which is just a special log, the natural log of 5x to the 7th over y. We are going to use more than one property most of the time. It's possible we only have to use one, but if we look at number 1, which properties do you see we're probably going to use? Yeah. Definitely quotient, there's 2 things divided. Definitely the power property because there's an exponent. There's actually all 3. But those 2, yes, for sure. There's also the product property because what 2 things are being multiplied together up top? 5 and x to the 7th. So we're going to use all 3. So this is a great one to start with. Always start by getting rid of the division. So let's use the quotient property. So I'm going to rewrite this as 2 separate logs. This log in this example is ln. So we'll do the ln of the top, and will we add or subtract? Subtract, because we're dividing. The ln of the top minus the ln of the bottom. The ln of the top minus the ln of the bottom. Okay? So we have started to expand. Quotient, done. Now here's the hard part. The question is, do I bring the exponent down now, or do I first separate them using the product property? If I bring this 7 down, out in front, what's wrong with that? There is an issue with that. What is that exponent directly connected to? The 7 is connected to the x, right? If I put the 7 out front, and you went to go put it back in, do you know if it's connected to the 5 or the x? No. So if you were to write 7 ln of 5x and go put it in front of Mr. Kravitz, and he wants to put that 7 back in, he doesn't know if it's supposed to go on the 5 or the x. If you put that 7 out front, it actually means that both things on the inside have an exponent of 7. So we need to first split up 5 and x to the 7th. they're being multiplied, so we'll write them as 2 ln's being added. So this will split into 2 more. We'll leave the ln of y. So we're going to have the ln of 5 plus the ln of x to the 7th. Again, these are adding because they were being multiplied before. And we still have minus ln of y. And now that I have my x to the 7th by itself, I can take that exponent and I can move it out in front. The ln of 5 plus 7 times the ln of x minus ln of y. This is totally expanded. And now, can't you clearly tell the 7 is supposed to be connected to the x and not to the 5, right? Now, if you were to put this one in front of Mr. Kravitz and he condensed, he would know, oh, the x has the exponent of 7, then I'm going to put the 5 with the x to the 7th, and then divide them. You know you are done expanding when, look at on the inside of these ln's. How many things are inside of them? Just one. There's no other property. Nothing being divided, no more exponents, nothing being multiplied. That is fully expanded, done. Two more. Number 2. This is a log base 6. That is the type of logarithm number 2 is. So whenever we are expanding and writing down a bunch of logs, they're all going to be log base 6. That 6 is just telling us what type of log it is. It's not a number that changes. It's not being multiplied or divided. It's just the type of log it is. Inside of this logarithm, there is a 3x to the 4th. Which properties will you use to expand? Or how many will you use? What all is happening with 3x to the 4th? Well, let's check. Are we dividing anything? Definitely not using the quotient. Is anything being multiplied? Yep. 3 times x to the 4th, so we're going to use the product. And are there any exponents? Yeah, so we're going to use the product property and the exponent, or the power property. 2 of our 3. This problem is actually easier than that first one. So, again, what should I do first? Should I bring down my exponents, or should I split them up with the product property? We're going to split it up with the product. Just like we said before, if we put the 4 out in front, then if someone went to put it back in, they wouldn't know what that's connected to. They don't know if they put the 4 back to the 3, or the 4 back to the x, or the 4 back to both. They don't know. So we need to split them up first. So log base 6 of the first thing being multiplied, a 3, plus, because it was multiplication, log base 6 of the second term being multiplied, x to the 4th. We literally just split it up into 2 logs. Log base 6 of 3, that only has one thing, so that's good. That's done. Nothing else to expand. Log base 6 of x to the 4th, although there's nothing being multiplied or divided, there is an exponent. And whenever we have an exponent, we grab it and we put it out in front. Log base 6 of 3 plus 4 log base 6 of x. If you look, how many things are inside the logs? There's 2 altogether, but there's only 1 thing in each, which means we are fully expanded. We are done. That is expanded.
I don't know what I did wrong.
I'm recording. Okay, 1 more for expanding. We're not going to do number 4. Number 3. Number 3 is an ln. That's a special type, that natural log. How many properties do you see? Which one? The 12 has an x by it, so that's multiplication, so that's a product property. There's 1 more. What's happening between the 5 and the 12x? Quotient. They're being divided. So quotient rule, product rule. I like to always start with the quotient rule. When 2 things are being divided on the inside, we rewrite it as 2 logs, in this case 2 ln's being subtracted. So I'm going to get the ln of the top term minus, because it's division, the ln of the bottom. Done. I mean, I'm done with that property, but we definitely have another one. Okay, now, ln of 12x. That is a 12 times an x. So they are being multiplied. Because they are being multiplied, we are going to split them up by adding 2 separate logs. Ln of 5 minus the ln of my first term, 12. Because they're being multiplied, am I going to do a plus or a minus? Plus ln of x. Each one of my logs, each one of my ln's, have 1 term inside. This one just has a 5, just has a 12, just has an x. There's no exponents. This is fully expanded. This is done. Okay, that is how you expand